Your IDE is obsolete. This agent reads your entire repository, every file, every dependency, and codes, debugs, and deploys without you ever needing to touch the keyboard. We are not here to talk about simple completions. We are deconstructing the architecture of a truly self-correcting AI agent, the blueprint for full-stack autonomy. The fundamental bottleneck in current AI coding tools is context. They operate linearly, prompt comes in, they generate output, and if it's wrong, the feedback loop is fragile. They treat a massive code base like a search query, a series of isolated calls. They don't understand the dependencies, the invariants, or the business logic woven across hundreds of files. The breakthrough isn't bigger models. It's a shift from linear prompting to deep, distributed memory indexing. Think of it as turning your entire repository into a semantic map. Each function, class, and variable isn't just text, it's a highly indexed concept within a vector database. When a task arrives, say, add user profile pagination, the agent doesn't search file names. It retrieves the conceptual solutions from disparate parts of the repo, the database schema, the API endpoint definition, and the front-end rendering logic. This ability to retrieve contextually relevant chunks, not just matching lines, is the foundation of deep code understanding. It's context density, not volume. But retrieval is only the first step. The second layer is the planning and execution module. The agent breaks down the high-level goal into a granular task tree. Task A requires task B, which depends on the successful completion of task C. It plans the sequence of file modifications. It determines which files need touch, in what order they must be addressed, and crucially, how those changes ripple through the system. This is where the self-correction loop begins. The agent doesn't just code, it simulates the execution. It compiles the code change into a difference. It runs unit tests against that difference, and if they fail, it doesn't just throw an error, it analyzes the failure mode. The failure isn't a roadblock, it's a targeted signal. The agent identifies the mismatch between its intent and the current system constraints. It uses the full context of the original repository to hypothesize fixes. It doesn't guess, it searches for patterns that led to similar successful resolutions in the codebase history. It iteratively refines the plan. Initial attempt failed due to race condition in module X. Second attempt addresses this by refactoring the transaction boundaries. This planning execution reflection cycle is the core difference between a helpful copilot and an autonomous agent. It is a cognitive loop. The agent manages its own memory, its own testing suite, and critically, its own failure modes. The ultimate goal is to reach a state of high-fidelity deployment readiness, where human intervention is reserved only for architectural pivots, not syntax errors. For the developer audience, this moves you from being a typist into an architect. You become the conductor of the symphony, not the violinist correcting every squeak. The challenge now is scaling this cognitive load. It requires robust middleware and a high-throughput communication layer between the LLM and the execution environment.